Hi friends, today's topic is multistage amplifier. So multistage amplifier is an electronic device consisting of two or more single stage amplifiers connected together, means connected in cascade form. So one of the single stage amplifier is connected to the next single stage amplifier. The output of the first single stage amplifier is connected to input of the second single stage amplifier by using the coupling devices. So this is the coupling devices. Okay, this is called multi-stage amplifier. Usually the multi-stage amplifier having high gain than the single stage amplifier. So here the single stage amplifier consisting of only one transistor, but multi-stage amplifier consisting of for two stage amplifier two transistor is present, for three stage three transistor is present, so on. Need for multi-stage amplifier. What is the need? So because the multi-stage amplifier having high gain than the single stage amplifier, so practically the single stage amplifier is usually insufficient to the output devices like speakers, etc. The because of the voltage gain is less. So that's why the single stage amplifier produces insufficient voltage to the load. So that's why we use multi-stage amplifier in that case. So this is the two-stage two-stage amplifiers. So here we have one single stage and second single stage. So these stages can be connected by using coupling devices. So here we have three types of coupling devices. So one is RC coupling, another one is direct coupling, another one is transformer coupling. Okay, so in this video we just discuss about the RC coupled multi-stage amplifier. So next, gain of a multi-stage amplifier. So gain is product of the individual stages. The gain of the multi-stage amplifier is the product of the gain of the means voltage gain of the individual stages or single stages. So for example, here we have two stage amplifier. The overall gain of the two stage amplifier is AV, so which is equal to V out by V in. So this is the overall gain of the two stage amplifier. So here there is a single stage. So here the gain of the single stage amplifier must means first stage amplifier is I write AV1, which is equal to, so output of the first stage amplifier is like V2 and input is V in. So this is V in, input of the first stage, and this is the V2 output of the first stage. Similarly, AV2 is the gain of the second stage amplifier, AV2. So here the input is nothing but the output of the first stage, V2. So output is V out. So here we write V out. So V out divided by V2. So I already tell that the gain of the multi-stage amplifier is the product of the individual gain. So that's why AV is equal to AV1 into AV2. So I already write the relation of AV1 and AV2. The gain of the multistage amplifier is AV is equal to V output by V in. So that's why the gain is higher than the single stage amplifier. So next, so let us talk about the RC coupled amplifier. So here this is the circuit of the RC coupled amplifier. So here we use capacitor CC for connecting the two single stage amplifiers. So from this circuit we have, this is the first stage or first single stage. So this is the second single stage. So this is the coupling capacitor. So here in this circuit we have the voltage divider biasing circuit. So this is the voltage divider biasing circuit. So because of using this voltage divider biasing circuit, we get the high stability and proper operating point of the transistor. So this voltage divider biasing also called self biasing, means here the IC, in case the IC changes, the this voltage divider biasing circuit, the whether IC is changes, so IC is decreases. So it is the uses of the voltage divider biasing. So self biased. So when it is increases, so then it is decreases. Next, here we have CE, means bypass capacitors. CE is also called bypass capacitor. So these bypass capacitors produces zero or low resistance path to the signal, means AC signal. Here AC signal. Next, CC is the coupling capacitors. So these coupling capacitors have some important role in the amplifiers. So because here we use CC, so this coupling capacitor offers high impedance to the DC signal and low impedance to the AC signal. That means open circuit for the DC signal and short circuit for the AC signal. Here we know the relations, means the capacitive reactance is given by Xc, which is equal to 1 divided by 2 pi Fc. So for DC, F is equal to 0, so Xc becomes infinity. So infinity means reactance is infinity. That means the impedance due to the capacitor is infinite. Infinite means for DC, the capacitor offers infinite resistance to the DC, means open circuit for the DC. Next for AC, so for AC, F is not equal to 0. So means F have some value. So that means Xc have some finite values. So for our AC, the reactance have some value. That means for AC, the capacitor offers some resistance, but it actually have for short circuit for the AC. So that means the coupling capacitors is blocks the DC and allows the AC signal from first stage to another stage. So here there is no, means absence of coupling capacitors. So here DC signal also passes through the first stage to the second stage. So here I am talking about the absence of coupling capacitor. So when the DC signal passes from one stage to another stage, the IB of the second stage is increases. So when IB is increases, when IB is increases, IC is also increases due to this relation. IC is equal to beta times IB. So when IB is increases, the Q point is shifted towards the saturation point. So here the Q point is shifted, the second stage have some distorted output or distorted AC signal is produced at the output of the second stage. So this is the use of the coupling capacitors. So next is frequency response curve. So it is the graph between frequency and the voltage gain. So your frequency along x-axis and the voltage gain along y-axis. So these graph represent or shows this like of this behavior. So at the lower frequency, so this stage at lower frequency, the gain is increases, means low, but frequency is increases, the gain is also increases. Next, at higher frequency, so in this range, in this region. So here the frequency is maximum or the frequency is increases, the gain is also decreases. Because so here the gain increases due to coupling capacitor CC. You know the XC capacitive reactant XC is equal to 1 over 2 pi FC. So XC is nothing but the impedance, impedance is nothing but the resistance offered by the capacitor. So here F is increases, XC becomes decreases. So here F is decreases, XC becomes increases. So at lower frequency in this region, F is very small, so XC becomes very high. So here the capacitor offers high resistance to the lower frequency and low resistance to the higher frequency. So because of this reason, so in this region means the lower frequency region, here the gain is increases with the frequency. Okay, next here at higher frequency, so here the bypass capacitor. So at higher frequency, so it is also capacitor, so it have some capacitive reactance 1 over 2 pi Fc. So for higher frequency, F is higher, so that's why Xc is low or very less. So from the circuit, you know, this is the C bypass capacitor. So it offers low resistance to the AC signal. So at a higher frequency, so CE offers very much lower resistance. So that's why, so for AC, that's for AC, not a DC. So because of this reason, the AC means AC component of the current is flows in this path. So all the AC current bypass towards the ground. So that's why the gain of the individual stages reduces. because of bypass capacitor at the range of the higher frequency range. So that's why with the frequency the gain is decreases in this region. So next, in the middle means so in this range, in this region the gain is constant. You know flat response means the gain is constant. So this is the frequency response of the RC coupled amplifier. So in the next video we talk about the direct coupling and transformer coupling of the multi-stage amplifier. So thank you.